इसका रिकॉर्डिंग करनी है इसका करना है।
यूट्यूब पे रिकॉर्ड हो रहा है वो आपका अलग से
चलो ठीक
ठीक है आवाज आपकी रिकॉर्ड हो रही
है ओके
है
so
व्हाट्स द में आपकी इंस्ट्रक्शन करा दूं आपको Assalamu alaikum everybody. So today we have a guest speaker lecture from Dr. Hamad Tanveer Bhatt. Because आज हमारी रेगुलर क्लास आप लोग नहीं है बिकॉज ऑफ दी छुट्टी बट ये कि हमने स्टिल सोचा कि डॉक्टर साहब को हमने इनवाइट किया था और डॉक्टर साहब काफ़ी बिजी आदमी है तो हम इसको रिकॉर्ड करेंगे आप इसको रिकॉर्डिंग पे जो है वो सुन लें एम ये है कि हमारा जो आज का टारगेट है वो ये कि हम क्वांटम कंप्यूटिंग का एक नया डोमेन है दुनिया में इस वक्त बूम कर रहा है और लोग इसमें काफ़ी काम भी कर रहे हैं और काफ़ी अपॉर्चुनिटीज़ हैं आगे फ्यूचरिस्टिक परस्पेक्टिव से Dr. Ahmad Tanveer Bhatt जो माशाल्लाह he is one of the excellent source in this domain. Dr. Ahmad को थोड़ा सा मैं इंट्रोड्यूस कर दूं कि he is the topper of metric board. Later on FSC में कैडेट कॉलेज सराय आलमगीर के पढ़े हुए हैं वहाँ से इन्होंने जो आपका ये फेडरल बोर्ड है वो भी टॉप किया हुआ है फर्दर CI नस्ट CI से ही इज द गोल्ड मेडल इन एवियोनिक्स इंजीनियरिंग बेस्ट इंजीनियर्स ट्रॉफी इनके पास है और 4 GPA के साथ ये ग्रेजुएट हुए हैं माशाल्लाह लेटर ऑन मास्टर्स में इन्होंने गोल्ड मेडल लिया हुआ है नस्ट से और PhD के लिए ये यूनिवर्सिटी ऑफ कार्लस्टेड गए थे जर्मनी और वहाँ से भी इन्होंने डिस्टिंक्शंस के साथ PhD की है और ये रिसेंटली लास्ट ईयर वापस आए तो अभी अपना ये काम भी कर रहे हैं और ही इज ऑल्सो इंटरेस्टेड टुवर्ड्स क्वांटम कंप्यूटिंग और उनके डोमेन्स में बायोमेडिकल साइड पे भी कुछ काम है और कुछ सेंसर से रिलेटेड और डीप लर्निंग और आर्टिफिशियल इंटेलिजेंस में भी काफ़ी इन्होंने काम किया हुआ है तो ही इज़ द एक्सीलेंट गाय टुवर्ड्स दिस एरिया तो हमने इनसे रिक्वेस्ट की थी कि थोड़ा सा अपना एक्सपीरियंस हमसे शेयर करें ताकि क्लास का और हमारे जो स्टूडेंट्स उनका फ़ायदा हो तो फोकस ये करेंगे टुवर्ड्स क्वांटम कंप्यूटिंग की बेसिक्स के ऊपर और उसकी एप्लीकेशंस टुवर्ड्स AI एंड डीप लर्निंग क्योंकि क्वांटम कंप्यूटर्स कैन बी यूज्ड फॉर ट्रेनिंग एंड लर्निंग पर्सपेक्टिव जो हम सीख रहे हैं जिसमें हमें टाइम बहुत लगता है तो क्वांटम कंप्यूटर्स वो दुनिया है जहाँ पे आप शायद जो काम 10 घंटे में होता है वो 10 सेकंड में या 10 मिनट में करने के काबिल हो सकते हैं तो वो एक जो आपके पास कंप्यूटिंग पावर आ जाएगी विद द हेल्प ऑफ क्वांटम कंप्यूटर्स दैट इज इनॉर्मस सो उस पर्सपेक्टिव से ये अपनी टॉक देंगे आज इसको हम रिकॉर्ड कर रहे हैं इसके 2 सेक्शंस होंगे एक सेक्शन जो है वो ऑलरेडी यूट्यूब पे अवेलेबल है सेकंड इंशाल्लाह आज हम रिकॉर्ड कर लेंगे काइंडली इसको देखिए एंजॉय करें और इससे अच्छी कोई चीज़ सीखने की कोशिश करें और अगर फ्यूचरिस्टिक आप इंटरेस्टेड हैं तो डॉक्टर साहब यहीं पे इनसे हम इंशाल्लाह इनका लिंक शेयर कर लेंगे एनीबडी हु इज इंटरेस्टेड टू वर्क towards this domain of quantum computing he or she is most welcome to work towards now I invite Dr. Hamad to start with his lecture.
Thank you very much, Dr. Iman Shafi, for very kind words and very detailed introduction. I never expected such a lengthy introduction. You have covered almost in the entire spectrum of how we can use the quantum computing. I've been missing 2 points because I've recently, yesterday only, I've attended a conference at NILO. Before that, last month we had a symposium in EME College on the quantum computing, and there was just talk of the town. And in a country like Pakistan, the DG Nilop was saying that in a country like Pakistan, in the last 9 months, this is the 10th conference which is happening, and there are more coming in the next few months. So just imagine the kind of hype. I would say it a hype because this field is old, but sometimes something takes just a start. Quick start. So this is what something that has happened recently in last 3-4 years. And now, even in a country, a dormant country like Pakistan, where we, are always behind in the technology, we are having so many conferences for the awareness only. What is the capability? I'll talk about that later. Definitely, we are always short on the capability, but definitely the hype and the motivation and the enthusiasm is there. That is one aspect. The other aspect that probably, we have missed is, and probably people have different opinions on this. Even in Nilop, I met the prorector over there of the PAS, and he was probably of the view that quantum computers will come, but the main computers, the kind of computers, the laptops on which we are recording, will probably stay. I a bit disagree with this. Because there are two things. If we can make the quantum computers scalable, and if we can miniaturize them, already we have seen the miniaturization of the integrated circuits. And they have almost taken the world by storm in the last 50 years, the information age that you say. has in the started with the electronics in the digital domain in digital computing. So if we can make them scalable and miniaturized, they will almost completely in many fields they will replace, because once you have the compute capability available, then it is just a matter of imagination and then working for the algorithms that can work on them. So personally speaking, I mean a bit disagree. I mean there can be two prongs which the future can take. One is that maybe the existing technology stays and quantum just becomes a niche technology. The other one is that quantum almost replaces it. I mean more towards biased towards the second thing, that probably the quantum is going to take everything by storm. And this is what is happening right now in front of our eyes, and we're watching it. I mean, perhaps you have not seen because you are kids of the internet age, but we have seen the internet take over in front of our eyes. I mean, it happened. I mean, right in front of our eyes, because we were doing the engineering at that time. So I mean, it is quicker than that. The quantum at the moment is quicker than that. So maybe just take a time frame of 5 years or 10 years. I mean, I would say 5 years that it is going to change. Next thing is, I mean, I think this class is of the mechanical engineers. Most people who think, I mean, a biologist, chemist, mechanical engineers, chemical engineers, why should we learn quantum computing? It is something related with the computer. So probably, I mean, the computer engineers should learn. So it's not like that. As a mechanical engineers, you are using the computers today for various purposes, simulations, modeling. I mean, even design at the moment, CAD, and probably this course is focused on that. So if you are today using those computers which are designed by somebody else and you're just utilizing them, so you will have to use these quantum computers also. Because if the compute capability is available and the algorithms are available, then probably, I mean, you will be the user at the application end. You have to use. So the second thing is, if you have to use them, then you have to at least understand something about them. I don't want I mean, become quantum mechanic experts. I'm not a quantum mechanics expert, and I am not selling quantum mechanics here. Because I mean, these days, if you attend any conference, most of the people or the top speakers will find the physicists, and they will give a very heavy talk. Although my talk will be a bit heavy also, but I'll try to keep it not as heavy as I listened yesterday, or as we listened from the physicists. Physicists take it from see it from a different perspective because they're into the design domain. We as engineers are in application domain. So if something is coming, we should be ready for it. We should be receptive for it, and we should be able to utilize it. That's should be the, I mean, the aim, the entire focus, or I mean the context in which we should be, I mean, learning this subject. So I'll cover this thing is in two phases. One is kind of a 18-minute pre-recorded talk that I gave last year in a workshop here, and I keep it pre-recorded, and I brought that instead of, I mean, explaining it again from zero, because if I'll explain, it will, I mean, become a bit lengthier. So since it is a very, I mean, crisp, and it is already uploaded on YouTube, so I mean, if even you don't understand, you can go back and watch it again and see, I mean, what you can make out of it. Then I'll link it to the AI, and second part I'll explain. So let's start with first the first part, the pre-recorded talk, and you can listen that. Understand it, and nobody does. The theory is absent from the quantum sense, but it works. So let us accept it and make use of it. The end point of our exploration of quantum computing, in my agrees with Max Planck's contention that we are not using the skeptics, but focus instead on moving a new generation will actually be able to apply quantum computing to real computing cases. The skeptics and the skepticism will pass away. Here is an outline of our introductory session program. I shall give a brief about our computing algorithms, in particular focusing on philosophy of computing. Then I will cover the brief history of quantum computing, mentioning its milestones. Some background mathematics and quantum mechanics to discuss next. Then I shall elaborate on what is quantum computing, so special in context, and why it outperforms other computing. I shall end this introductory session by getting it. That is what quantum computing is.
or not, we should not expect to perform. Finally, I should note that we still need more progress, technology, and further research to come up with real world use cases. Let us first define definition. A universal computer is in fact a programmable machine that processes input information to give output information via a logical sequence of instructions. The compilation is the physical process of this machine. Java may have been multiple substance. Purpose is to solve a compilation problem. Many different types of compilation problems exist in different ways. Example of function, knowledge, and optimization. Let's look into one such class and a CM problem. It maps input information to a segment yes or no. It is forwarded to a Boolean function which maps a binary string of input information to a single Boolean value, 0 or 1. As we all know, that every Boolean function that we take a string of every implementation. The complexity of computational problem is determined by the resources it needs, or equivalently cost in terms of space and time. Or given problem, the space and time can be written off. The complexity characterizes how space and time requirements grow in the cycle, which is the number of bits used at that moment. For plus